March 17, 1943, 7 kilometers outside Kasserine Pass, Tunisia. The morning sun had barely crested the eastern ridgeline when Oberfeldwebel Klaus Zimmermann spotted the abandoned vehicle. It sat tilted at an awkward angle in a shallow wadi, its olive-drab paint barely distinguishable from the surrounding rocks and scrub. His reconnaissance patrol had been working this sector for 3 days, mapping American positions after the recent fighting, cataloguing abandoned equipment, searching for anything useful in the wreckage of war. Zimmermann raised his hand, signaling the patrol to halt. The 4 men behind him dropped into defensive positions automatically, rifles ready, eyes scanning for ambush. 2 weeks had passed since the Americans had been pushed back through Kasserine Pass in chaotic retreat, but Tunisia remained contested ground. Abandoned vehicles could be booby-trapped. He studied the vehicle through his binoculars for a full minute. Small, boxy, open-topped. Definitely American. No visible damage. The crew had simply abandoned it, probably during the panicked withdrawal when Rommel's counterattack had caught American forces unprepared. Standard Wehrmacht procedure dictated destroying abandoned enemy equipment, but Klaus Zimmermann was a practical man. He had served since 1936, 7 years that had taken him from Bavaria through Poland, France, the Balkans, and now this cursed desert. His reconnaissance battalion was chronically short of vehicles. Fuel was rationed. Replacement equipment arrived months late, if it arrived at all. If this American vehicle was functional, it represented transportation his unit desperately needed. Hartmann, Schneider, with me. Fischer, Koenig, maintain position and cover us. They advanced carefully, weapons ready. No movement, no sounds except wind whistling through the rocks. The vehicle appeared genuinely abandoned. Up close, it looked unimpressive. Flat steel panels stamped into, basic shapes, minimal bodywork, exposed rivets everywhere, a folding windscreen, simple canvas seats, no doors, no roof, no weather protection. The whole thing looked like something a farmer might cobble together, not a military vehicle produced by a modern industrial nation. Zimmermann circled it slowly. A small metal plate riveted to the dashboard read Willys MB along with a serial number and production date. September 1942. 6 months old, practically new. The Americans called these machines jeeps. He had heard rumors about them, whispered conversations in motor pools. Intelligence reports that seemed too optimistic. German soldiers who had encountered them spoke with grudging respect. They described vehicles that could traverse terrain that would stop a Kübelwagen, that required minimal maintenance, that seemed present in unlimited quantities. Zimmermann had dismissed most of these stories as exaggeration. But now he had an intact example before him. Hartmann, get the toolkit. I want to examine this thing properly. While the soldier retrieved tools, Zimmermann continued his inspection. The exterior finish was adequate but unsophisticated. Paint applied in thick coats, welds functional but crude, panel gaps inconsistent. By German manufacturing standards, the quality control was appalling. The Kübelwagen his unit used was designed by Ferdinand Porsche. It had flowing lines, precise panel fits, clean welds, every component engineered to exacting specifications. Looking at it next to this crude American machine was like comparing a Swiss watch to a hammer. Yet the Jeep was here, functional, apparently reliable enough for American combat deployment. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The tires were surprisingly large, mounted on simple steel wheels. The tread pattern was aggressive, designed for traction in loose soil. The suspension was immediately visible. Simple leaf springs front and rear, the most primitive technology imaginable. The Kübelwagen used sophisticated torsion bars that provided excellent ride quality while reducing weight. German engineers had abandoned leaf springs decades ago as obsolete. But as Zimmermann examined the leaf springs more closely, understanding dawned. Torsion bars required precise metallurgy and careful assembly. They needed specialized facilities and skilled workers. If one broke in the field, replacement meant returning to a depot. Leaf springs were just strips of steel stacked together. Any blacksmith in any village could repair them. A field mechanic with basic tools could fabricate replacements from scrap. In a global war spanning continents, perhaps crude reliability trumped sophisticated efficiency. Hartmann returned with tools. Zimmermann opened the hood. What he saw made him pause. The engine bay was remarkably clean and organized, every component clearly, visible and accessible. Color-coded wires ran along marked paths. Fluid reservoirs were labeled. Major components had identification tags. In 2 decades working on German military vehicles, Zimmermann had never seen such deliberate simplification. German engines were masterworks of precision engineering, components packed tightly to minimize size and weight. They required trained mechanics, proper tools, clean workshops. This American engine looked designed by someone who assumed the mechanic would be an 18-year-old farm boy working at night, in the rain, possibly under enemy fire, with only basic tools available. The Go Devil engine, 134 cubic inches, producing 60 horsepower at 4,000 RPM. He did the mental arithmetic. The Kübelwagens air-cooled flat 4 produced 50 horsepower from just 85 cubic inches, nearly 30% more efficient in power density. But power density wasn't everything. The American engine used simple, flathead valves, the most basic configuration possible, single carburetor with straightforward adjustment screws, mechanical fuel pump serviceable with common tools, distributor mounted in an easily accessible location, spark plugs reached without removing other components. The Kübelwagens engine was an engineering triumph, requiring careful maintenance by trained personnel. This American engine sacrificed some performance to achieve something perhaps more valuable, maintainability by anyone with minimal mechanical knowledge. "Schneider, help me check the running gear. I want to see how this thing moves." They crawled underneath. The chassis was a simple ladder frame, 2 parallel steel rails connected by crossmembers. Crude compared to the Kübelwagen's sophisticated platform chassis, but extremely strong. The frame rails were thick, overbuilt, designed to handle punishment that would buckle lighter structures. Then Zimmermann noticed something that made him stop. The front axle was a solid beam, which he expected. But this axle had features he didn't expect on a light vehicle. The axle housing had a differential in the center. There were also universal joints at both ends, connecting to half shafts running into the wheel hubs. He followed the driveline back from the transmission. A transfer case sat behind the gearbox, a secondary transmission with its own lever protruding from it. The transfer case had 2 outputs. One drive shaft ran backward to the rear axle, standard, but a second drive shaft ran forward to the front axle. Both axles had differentials. Both axles had driven wheels. The transfer case could send power to both front and rear axles. 4-wheel drive. The Americans had installed a 4-wheel drive system on a light reconnaissance vehicle. He crawled out and sat on the running board, processing the implications. 4-wheel drive wasn't new technology. Specialized vehicles had used it for years. Heavy trucks for extreme conditions, experimental machines. But those systems were complex, expensive, difficult to maintain. They added significant weight, reduced fuel efficiency, and required skilled operators. The Kübelwagen was rear-wheel drive only, as were virtually all German light vehicles. The reasoning was sound. Rear-wheel drive was simpler, lighter, more fuel-efficient. German military doctrine emphasized that skilled driving technique could overcome most terrain challenges. But the Americans apparently rejected that entire philosophy. They had decided mechanical complexity of 4-wheel drive was worth it for go-anywhere mobility. They had engineered a system simple enough for mass production and reliable enough for standard equipment. Zimmermann examined the transfer case more closely. The engagement lever was marked with simple positions. 2H for 2-wheel drive high range, 4H for 4-wheel drive high range, N for neutral, 4 liters for 4-wheel drive low range. A single lever controlled everything. German vehicles with 4-wheel drive, very few existed, required complex procedures to engage the system, multiple operations, careful coordination, specific sequences. Operators needed training and experience. This American system was designed for simplicity. Pull the lever to 4H and all 4 wheels were driven. Pull it to 4 liters and you got 4-wheel drive plus dramatically reduced gearing for climbing obstacles. Any soldier could learn it in 5 minutes. Check the fuel level, Zimmermann ordered. Hartmann checked the tank. Maybe half full, sir. 7 or 8 gallons. Enough for a test drive. Let's see if we can start it. They spent 15 minutes checking electrical connections. The battery showed residual charge but wasn't delivering power to the starter. Zimmermann traced wires until he found a loose connection at the starter solenoid. He tightened it with a wrench. Try it now. Hartmann turned the key. The starter engaged. The engine turned over, coughed, then caught. It ran roughly for several seconds as fuel worked through the carburetor, then settled into a steady idle. The exhaust note was distinctive, a peculiar low rumble, almost agricultural. The engine wasn't sophisticated or refined, but it ran. Oil pressure was good, temperature remained normal. Zimmermann let it warm up for several minutes, then pressed the clutch and tested the gear shift. It moved easily through the H pattern. He selected first gear and slowly released the clutch while adding throttle. The Jeep lurched forward, then stalled. Too much throttle. He started it again and tried with more care. This time the vehicle crept forward smoothly. The steering was heavy but direct. The ride was harsh. Those primitive leaf springs transmitted every bump directly to the chassis. The seating position felt exposed. No roof, no doors, just a folding windscreen. But visibility was outstanding. For reconnaissance work, this was invaluable. The vehicle was remarkably maneuverable. The short wheelbase allowed him to spin the Jeep around in spaces that would require a 3-point turn in a Kübelwagen. He drove it around the wadi, testing controls and getting a feel for the machine. In 2-wheel drive on firm ground, it handled adequately. Nothing exceptional. The Kübelwagen was lighter, more nimble, quicker to respond. Then Zimmermann spotted a patch of soft sand, the kind that plagued every vehicle in North Africa. He approached at moderate speed, as doctrine taught. The front wheels hit the sand and carved through reasonably well, but the rear wheels immediately began to slip. The Jeep slowed, wallowing as the powered rear wheels spun. Zimmermann reached for the transfer case lever and pulled it back to the 4H position. He felt a solid mechanical engagement. 4-wheel drive activated. The transformation was immediate and dramatic. The front wheels, now powered, dug into the sand with authority. All 4 wheels clawed at the loose surface, and the Jeep surged forward with renewed purpose. The difference wasn't subtle. It was overwhelming. Where a rear-wheel drive vehicle would have required careful technique to maintain momentum, the Jeep simply powered through. Zimmermann didn't need to choose his line carefully or maintain precise throttle control. He just pointed the vehicle where he wanted to go and applied power. He deliberately drove deeper into the soft sand, seeking the worst terrain. The Jeep kept going. He slowed to walking speed. Even with all 4 wheels churning through sand that came up to the axle centerlines, the vehicle maintained forward motion. He stopped completely, letting the Jeep settle. This was the moment of truth. In a Kübelwagen, stopping in soft sand meant you were stuck. Zimmermann released the brake and smoothly applied throttle. All 4 wheels spun briefly, then bit into the sand and pulled the vehicle forward. It was that simple. No technique required, just point and go. Then he found what he was really looking for: a steep embankment, approximately 30 degrees of incline covered in loose soil and small rocks. In a Kübelwagen, this would require a running start, careful throttle control, and precise line choice. Even then, success wasn't guaranteed. Zimmermann stopped the Jeep at the base and pulled the transfer case lever forward into the 4 liters position, 4-wheel drive, low range. He felt the mechanical engagement, more substantial than the shift to high range. The gearing dropped dramatically. With the clutch out and engine at idle, the Jeep crept forward at barely walking speed. He aimed directly up the embankment and applied steady throttle. The vehicle began climbing. The engine laboured but never strained. All four wheels gripped the loose soil, each one clawing for traction, and the jeep crawled up the slope. Halfway up, he performed the ultimate test. He stopped. The jeep sat motionless on the 30-degree incline, held by engine compression and the brake. A Kübelwagen in this position would slide backward, unless the driver was extremely skilled. Zimmermann released the brake. The jeep stayed motionless for a heartbeat, held by compression braking. He applied throttle. All four wheels bit into the soil, and the vehicle resumed climbing as if on level ground. No rollback, no wheel spin, no drama, just steady, inexorable forward motion. He crested the embankment and sat at the top, engine idling, thinking about what he had just experienced. This wasn't sophisticated engineering in the sense of advanced technology. This was functional engineering, identifying the tactical requirement and implementing the simplest possible solution. The tactical requirement was go-anywhere mobility. The solution was four-wheel drive with low-range gearing, operated by two simple levers any soldier could master in 5 minutes. The implications cascaded through his mind. If every American reconnaissance vehicle had this capability, their operational flexibility exceeded German equivalents enormously. They could traverse terrain that would stop a Kübelwagen. They could maintain mobility in conditions that would bog down German units. They could supply forward positions across country German doctrine considered impassable. More troubling was what this represented about American industrial capacity. Four-wheel drive systems were complex and expensive to manufacture. Germany couldn't afford to put them on standard light vehicles. Yet here was evidence that America was producing them as standard equipment. He drove the jeep back to where his assistant waited. "Get in. We're taking this back to the unit. The commanding officer needs to see this." They loaded their equipment. The drive back to German lines took an hour. Zimmermann kept the jeep in four-wheel drive for most of the journey, experimenting with its capabilities. Rocky terrain that would have required careful navigation in a Kübelwagen was simply traversed. Mud patches that would have meant detours were crossed directly. Sand that would have necessitated momentum techniques was powered through. Every minute reinforced his initial assessment. This was a superior vehicle for wartime reconnaissance, not because it was better engineered in any absolute sense, but because it was better designed for tactical realities. When they arrived at the unit's forward position, other soldiers gathered around the captured vehicle. Most had heard rumours about jeeps. Few had seen one up close. Zimmermann let them examine it while he went to find the commanding officer. Hauptmann Werner Schulz was a career officer, 42 years old, who had fought in Poland, France, and now Africa. He understood that wars were won through logistics, production, and sustainability, not just tactical brilliance. "Sir," Oberfeldwebel Zimmermann reporting, "we recovered an intact American light vehicle. It has capabilities that I believe you should see personally." Schulz looked up from his maps. "Kind of capabilities?" "Four-wheel drive, sir. Low-range gearing. Go-anywhere mobility with simple operation. I believe this vehicle represents a significant tactical advantage for the Americans." Schulz's eyebrows rose. "Four-wheel drive on a light vehicle? That's extremely difficult to mass-produce. This must be specialized equipment. Sir, the vehicle appears completely standard. There's no indication it's a specialty variant. The engineering is deliberately simplified for mass manufacturing. I believe the Americans have solved the production complexity that has prevented us from doing the same." Schulz set down his pencil. "That's a significant claim. Show me." They walked to where the jeep sat. Schulz circled it slowly, his experienced eye assessing. Like Zimmermann's initial reaction, his first impression was dismissive. The vehicle looked crude, unsophisticated. "Open the hood," Schulz ordered. Zimmermann lifted the clamshell hood. Schulz studied the engine in silence, then reached in to touch various components. He traced wiring. He examined mounting brackets. "This is designed for field maintenance by unskilled personnel," he said finally. "Everything is accessible. Everything is labelled. This isn't an engine designed to achieve optimal performance. It's designed to be serviced by farm boys. Yes, sir. That appears to be the entire design philosophy. Show me the four-wheel drive system. They crawled underneath together. Zimmermann traced the driveline, explaining the transfer case, the front differential, the engagement mechanism. He pointed out the simplicity, a single lever for engagement, robust components, straightforward operation. Schultz examined everything carefully. When they emerged, his expression was grave. Demonstrate the capabilities. Zimmermann drove Schultz around the immediate area, showing him everything he had discovered. He traversed soft sand that would bog down a Kübelwagen. He climbed an embankment that would require a running start in a German vehicle. He crawled over rocks at walking speed. Throughout the demonstration, Schultz said nothing, but Zimmermann could see his expression growing increasingly troubled. When they returned, Schultz sat silently for a long moment. How many of these do the Americans have? Unknown, sir. Intelligence reports have been vague. Schultz climbed out and stood looking at the Jeep. I want a complete technical assessment. Document everything. Specifications, capabilities, design philosophy. I'm forwarding this to divisional intelligence. They need to understand what we're facing. He paused. And Zimmermann, if the Americans can mass-produce vehicles with capabilities our specialized vehicles lack, that tells us something important about their industrial capacity, something we may have been underestimating. Over the next 3 days, Zimmermann assembled a team of mechanics and conducted exhaustive tests. They measured performance across every terrain type. They timed acceleration. They tested climbing ability. They calculated fuel consumption. They disassembled components to understand manufacturing techniques. The resulting report was 23 pages long, illustrated with photographs and detailed drawings. Zimmermann wrote it carefully, trying to convey not just the specifications but the philosophy behind them. The report opened with basic specifications. The numbers weren't particularly impressive compared to German equivalents. The Jeep was heavier, consumed more fuel per kilometre, and produced less power per unit of displacement. But Zimmermann devoted most of the report to explaining what those numbers meant in practical terms. The extra weight was structural margin, allowing the vehicle to survive overloading. The lower power density was a deliberate choice, prioritizing reliability. The higher fuel consumption was acceptable because American logistics could supply fuel in quantities German forces could only dream of. He documented the four-wheel drive system extensively. Detailed drawings showed how the transfer case worked, how power was distributed, how the engagement mechanism functioned. He explained that any soldier with minimal training could operate the system. The maintenance section emphasized how the entire vehicle was designed for field serviceability. Common fasteners requiring only basic tools, accessible components not requiring disassembly of surrounding systems, clear labeling eliminating guesswork, robust construction tolerating imperfect repairs. Zimmermann included a comparison analyzing the Jeep against the Kübelwagen. In technical sophistication, the Kübelwagen was superior. In power-to-weight ratio, fuel efficiency, and ride quality on paved roads, the Kübelwagen excelled. But in terrain capability, the Jeep was overwhelmingly superior. In ease of maintenance, far better. In durability under abuse, it exceeded German equivalents. In suitability for mass production, the Jeep represented a different category entirely. The conclusion was carefully worded but unambiguous. This vehicle represents a design philosophy optimized for total war. The Americans have prioritized production volume over individual vehicle perfection, simplicity over sophistication, field reliability over optimal efficiency. In sustained combat operations with minimally trained personnel and strained logistics, this approach may prove more effective than our emphasis on engineering excellence. The report made its way through channels. Within 2 weeks, Zimmermann received orders to brief divisional staff on his findings. The briefing took place at a villa near Tunis that division had requisitioned for headquarters. The briefing room held a dozen officers, 2 Hauptmen, several majors, 3 Oberstleutnants, and presiding over it all, Oberst Friedrich Müller, the division's intelligence chief. Zimmermann stood at attention as Müller reviewed his credentials. Oberfeldwebel Zimmermann, you've prepared a report on a captured American vehicle. Your chain of command considers it significant. Brief us on your findings. Zimmermann began with basic specifications, using a chalkboard to write out key numbers: length, width, height, weight, engine displacement, horsepower, maximum speed, range. One of the majors interrupted. Those specifications are unimpressive. Why should we be concerned? Zimmermann had anticipated this. Sir, the significance isn't in the specifications themselves, but in what they represent about American design philosophy. May I continue? Müller nodded. Proceed. Zimmermann explained the 4-wheel drive system using diagrams. He emphasized the simplicity of operation, a single lever, no complex procedures, instant engagement. He described the low-range gearing that multiplied torque. Several officers looked skeptical. 4-wheel drive on a light vehicle is prohibitively expensive, one Oberstleutnant said. This must be specialized equipment. Pulled out photographs of data plates and production stampings. Sir, all evidence suggests this is standard equipment. The serial number implies thousands of similar vehicles. The manufacturing quality indicates assembly line production. The parts standardization suggests mass manufacturing. He explained what his team had discovered about component interchangeability. Every fastener was standard. Every electrical connection matched a common specification. Every mechanical part appeared identical across the vehicle. Another officer spoke up. Even if they can produce these in quantity, surely the complexity limits their numbers. Zimmermann chose his words carefully. Sir, the Americans appear to have simplified the system specifically for mass production. The transfer case uses straight-cut gears rather than helical gears, easier to manufacture. The engagement mechanism is purely mechanical with no hydraulics. The front differential is a straightforward design, not requiring precise shimming. Every aspect has been engineered to minimize manufacturing difficulty. The room fell silent. Müller leaned forward. You're suggesting the Americans have deliberately sacrificed engineering sophistication to achieve manufacturing simplicity? Yes, sir. And I believe it's proving effective. This vehicle isn't optimally engineered by German standards, but it's excellently designed for mass production and field use. Zimmermann spent the next 20 minutes walking through performance comparisons. He showed photographs of the Jeep traversing challenging terrain. He presented fuel consumption data, maintenance requirements, reliability assessments. One major who had remained silent finally spoke. I commanded a reconnaissance company in France. Our Kübelwagens were excellent machines in skilled hands, but we lost vehicles to mechanical failures, terrain damage, maintenance issues. If this American vehicle is more forgiving of poor operation and easier to maintain, that's a significant tactical advantage. Precisely, sir, Zimmermann agreed. Müller called for silence. Let's discuss implications. If these vehicles are as numerous as Oberfeldwebel Zimmermann suggests, what does that mean for our operations? The discussion that followed was sobering. If American reconnaissance units had mobility advantages, German positions would be more easily scouted. If American supply vehicles could traverse poor roads or cross-country routes, their logistics would be more flexible. The operational implications favored the Americans. One officer raised the question of production capacity. Surely they can't produce these in quantities that would matter strategically. Müller pulled out an intelligence summary. Gentlemen, we've received reports from multiple sectors about encounters with these vehicles. Our forces have captured or observed approximately 24 British intelligence suggests American production numbers may be in the thousands per month. The room erupted, in skeptical exclamations. Thousands per month was impossible. Müller raised his hand for quiet. I understand your skepticism, but consider what we know about American industrial capacity. Their automotive industry produced 4 million civilian vehicles per year before the war. If they've designed this vehicle for mass manufacturing, perhaps such production rates are possible. The discussion continued. Some dismissed the Jeep as insignificant. Others recognized it as evidence of American capabilities German intelligence had underestimated. Finally, Müller brought the discussion to a close. This report will be forwarded to Oberkommando with my endorsement. We need better intelligence on American production numbers and capabilities. Dismissed. As officers filed out, Müller called Zimmermann back. That was well done, Oberfeldwebel. You've provided valuable intelligence, but I suspect you understand something that some of these officers don't. This isn't just about one vehicle. It's about what that vehicle reveals. The Americans aren't trying to build the best vehicle. They're trying to build adequate vehicles in overwhelming numbers. That's a different strategy than ours, and I fear it may prove more effective. Zimmermann nodded slowly. Yes, sir. That's exactly what troubles me. When Zimmermann returned to his unit, word of the captured Jeep had spread. Other German units wanted to examine it. Over the next week, mechanics and officers from 3 different battalions visited. The reactions followed a predictable pattern: initial skepticism about its crude appearance, growing respect as they examined the engineering, dismay when they understood the implications about American production capacity. By April 1943, Zimmermann's Reconnaissance battalion had captured 3 more Jeeps. All were pressed into German service immediately. Soldiers competed to drive them. Officers preferentially used Jeeps for forward reconnaissance because they trust the 4-wheel drive capability. A pattern emerged. On paved roads or firm terrain, German soldiers preferred the Kübelwagen, but in challenging terrain, soft sand, steep grades, muddy conditions, everyone wanted the Jeep. The 4-wheel drive was simply superior. Zimmermann found himself becoming the unit's resident expert on American vehicles. Whenever they captured equipment, he was called to assess it. He examined trucks, half-tracks, scout cars, command vehicles. Each reinforced his initial assessment. American equipment was engineered for mass production and field reliability, rather than optimal performance. In early May, his unit captured an American supply depot hastily abandoned during a German counterattack. Among the supplies were maintenance manuals for various vehicles. Zimmermann spent an evening studying the Jeep manual, translated with difficulty through his limited English and help from a soldier who had studied in America before the war. The manual was revealing. Written at approximately a 6th grade reading level, it assumed the reader had minimal mechanical knowledge. Every procedure was explained in simple steps with clear illustrations. Maintenance schedules were straightforward. Troubleshooting guides walked mechanics through common problems using decision trees that required no diagnostic expertise. The philosophy was unmistakable. Design the vehicle so anyone can fix it, then provide manuals that teach anyone how to fix it. This was the opposite of German practice, which assumed trained mechanics working from detailed technical specifications. Zimmermann showed the manual to his battalion's maintenance officer, Lieutenant Bergmann. The lieutenant studied it with increasing amazement. This is written for children. Any factory worker could learn vehicle maintenance from this. That's the point, I think, Zimmermann replied. They're mobilizing their entire population for war production. They need people with minimal training to maintain equipment, so they design the equipment to be maintainable by people with minimal training. Bergmann flipped through pages showing exploded diagrams. You know what this means? If they can train anyone to be a mechanic, they have unlimited maintenance capacity. We require skilled technicians who need years of training. They can create mechanics in weeks. The implications took days to fully appreciate. Germany's military effectiveness relied heavily on skilled personnel. Mechanics, technicians, specialists. These were resources that required time to develop and couldn't be easily replaced. If America could achieve adequate results with minimally trained personnel, their human resources were effectively unlimited. On May 13, 1943, the Afrika Korps surrendered in Tunisia. Approximately 250,000 German and Italian soldiers became prisoners of war. Zimmermann was among them. His war was over, but his education in American capabilities was just beginning. The surrender itself was almost anticlimactic. German and Italian forces had been compressed into a shrinking perimeter around Tunis and Bizerte. Supplies had been cut off, fuel was exhausted, ammunition was depleted. When the order came to lay down arms, Zimmermann felt neither surprise nor shame. They had fought well. They had been defeated not through tactical incompetence, but through material insufficiency. The processing of prisoners took days. American and British forces had to organize transportation, feeding, and security for 250,000 captives. Zimmermann and his unit were marched to a collection point near Tunis, where they waited in improvised camps. During that wait, Zimmermann observed American logistics in operation. The scale was staggering. Thousands of trucks moved supplies in organized convoys. Jeeps darted everywhere carrying officers, messages, and small cargoes. Tank transporters moved armor. Half-tracks served as personnel carriers and mobile command posts. Everything was motorized. He saw no horses, no ox carts, no human porters. The Americans moved everything with vehicles, and they had vehicles in such abundance that they seemed to waste them casually. Zimmermann watched American soldiers use a perfectly functional jeep to move a single box of paperwork 50 meters. In the Afrika Korps, such a journey would have been made on foot, conserving precious fuel. The contrast between German and American logistics couldn't be ignored. German supply lines had relied on a patchwork of vehicles: German trucks, captured British vehicles, Italian transports, civilian automobiles pressed into service. Spare parts were chronically short. Fuel was rationed. Every vehicle was precious. The Americans appeared to have unlimited everything. If a vehicle broke down, another replaced it. If fuel was needed, tank trucks delivered it. If parts wore out, supply depots provided replacements. The entire system operated with mechanical efficiency that made German logistics look improvised. At the port of Oran in Algeria, prisoners boarded ships for transport. Zimmermann was assigned to a Liberty ship, one of the mass-produced American cargo vessels turning the tide of the Atlantic shipping war. The ship itself was a revelation. Liberty ships were welded rather than riveted, a construction method allowing rapid assembly. The vessel Zimmermann boarded had been completed in just 47 days, according to a plaque in the hold. German shipyards took months to build vessels of similar size. During the crossing, Zimmermann talked with other prisoners, comparing observations and trying to understand what they had experienced. A common theme emerged. The Allies had won through material superiority. German soldiers had been skilled and courageous. German officers had been tactically competent, but the Allies had more of everything. A captured artillery officer summarized it: "We had better guns. They had more shells. We had better tanks. They had more tanks. We had better training. They had more soldiers. In the end, more beat better." The permanent prisoner camp was at Camp Hearn in Texas. The journey from North Africa to America took 3 weeks, moving through various processing centers. At each stop, prisoners witnessed American production capacity operating at scales that defied German preconceptions. The port at Norfolk, Virginia, processed thousands of tons of supplies daily with mechanical efficiency. Cranes loaded and unloaded cargo at speeds that would have required armies of workers in Hamburg. Trains carried prisoners across America in passenger coaches. And everywhere were vehicles. Cars filled parking lots outside factories. Trucks lined highways in convoys stretching for miles. Military vehicles sat in depot yards by the thousands awaiting shipment. At Camp Hearn, skilled mechanics like Zimmermann volunteered for the motor pool. American camp commanders welcomed their expertise because the war effort demanded every available worker. For the next 2 years, German mechanics worked alongside American soldiers, maintaining the vehicles that kept the camp running. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. American mechanics approached vehicle maintenance with direct practicality. They weren't engineers striving for perfection. They were problem solvers, focused on keeping equipment operational. When something broke, they fixed it quickly with whatever was available. When parts weren't available, they improvised. When a vehicle proved unrepairable, they cannibalized it for components and requested a replacement, which arrived within days rather than weeks. The captured mechanics observed American techniques closely. German mechanics were trained to maintain vehicles to factory specifications, requiring specialized tools and proper procedures. American mechanics were trained to keep things running by any means necessary. In peacetime conditions, German methods produced better results. In wartime chaos, American methods proved vastly more effective. The motor pool at Camp Hearn processed hundreds of vehicles monthly. Jeeps came in for routine maintenance, received service in hours rather than days, and returned to service. The efficiency came from parts abundance and component interchangeability. When a part needed replacement, the parts room had dozens in stock. When a tool was required, the tool room provided it immediately. One German mechanic befriended an American soldier who had worked for Ford before the war. The American proved knowledgeable about the automotive sector. Before the war, I worked on the assembly line at Willow Run. That's Ford's bomber plant outside Detroit, biggest factory in the world. We're building B-24 Liberators. Started production in '42. By the time I got drafted last year, we were completing one bomber every hour. Every single hour, a complete 4-engine heavy bomber rolled off that line. The arithmetic was staggering. 24 bombers per day, over 700 per month. How is such production possible? Mr. Ford figured out how to break down complex manufacturing into simple, repeatable steps. You don't need skilled craftsmen if every worker does one simple task repeatedly. A kid, fresh off the farm, can be trained in a week to install one type of bolt in one location. Do that with 1,000 workers and you get massive output. This was the fundamental difference. German production relied on skilled craftsmen building quality products in moderate quantities. American production relied on semi-skilled workers building adequate products in massive quantities. The American continued, "Same thing with Jeeps. Willys Overland makes them. So does Ford. Both plants use identical specifications. A part from a Willys Jeep fits a Ford Jeep perfectly. They're completely interchangeable. That means if one plant gets bombed or has problems, the other keeps producing. Maintenance is simple because every mechanic learns one vehicle, not dozens of variants." Zimmermann thought about the Wehrmacht's vehicle inventory. Dozens of different truck types from different manufacturers, each with unique parts and maintenance requirements. Kübelwagens from Volkswagen, command cars from various sources, captured vehicles from across Europe, each requiring its own spare parts and knowledge base. German logistics were a nightmare of incompatible systems. American logistics were streamlined through uniformity. The real genius is that we designed for manufacturability from the start. When they put out the requirements for the Jeep back in '40, they gave companies just 75 days to produce a prototype. American Bantam did it in 49 days. Then Willys and Ford refined the design for mass production. Everything had to be simple to manufacture, simple to maintain, and simple to repair. The captured mechanics had examined enough Jeeps to recognize this truth. The vehicle wasn't elegant. German engineers would have designed something more sophisticated, but sophistication impeded mass production, and mass production was winning the war. By summer of 1944, prisoners had heard rumors of Operation Overlord, the Allied invasion of Normandy. When news arrived of the landing's success, many felt no surprise. The Allies had the manufacturing capacity to build an invasion fleet that would have taken Germany years to assemble. News filtered into the camps through American newspapers and radio broadcasts. They read accounts of the Normandy beaches where Allied forces had landed with thousands of vehicles in the first wave alone. Jeeps, trucks, tanks, amphibious vehicles, all carried across the English Channel in purpose-built landing craft themselves manufactured by the thousands. The scale defied comprehension. 6,000 ships, 11,000 aircraft, 150,000 men in the first wave. Within weeks, millions of Allied soldiers would be fighting in Europe, all supplied by a production base that created equipment faster than the Wehrmacht could destroy it. German prisoners reflected on their pre-war confidence in victory. That confidence had been based on assumptions about German technological superiority. Those assumptions proved incomplete. Germany had superior engineering in many areas. German tanks were more heavily armoured. German aircraft were often more sophisticated. German small arms were excellent. But none of that mattered when America could produce 5 tanks for every one Germany built, 10 trucks for every German truck, 100 jeeps for every Kübelwagen. In the motor pool one afternoon, prisoners watched American soldiers loading jeeps onto transport trucks for shipment to the port. A young private drove each jeep up the loading ramps with casual confidence. Dozens of vehicles loaded in less than an hour, all bound for Europe to replace losses and supply new units. One German mechanic realized that this single loading operation at one camp in Texas represented more vehicles than his entire division had possessed in North Africa. This scene was being repeated at camps and depots across America every single day. The mathematics became inescapable. Germany had mobilized its economy for total war, stripping civilian production to support military manufacturing. Yet German military vehicle production in 1943 totaled less than 100,000 units of all types. America, maintaining a thriving civilian economy, produced over 2 million military vehicles the same year. The disparity wasn't just quantitative, it was qualitative. American vehicles were designed for wartime realities: ease of maintenance, interchangeable parts, simple operation, rugged reliability. German vehicles were engineered to specifications that made sense in peacetime but proved impractical in sustained combat. In November 1944, news reached the camp of a German offensive in the Ardennes, what would become known as the Battle of the Bulge, Hitler's last gamble in the West. The offensive relied heavily on capturing American fuel supplies, because Germany no longer had sufficient fuel to sustain armoured operations. More troubling were reports of Operation Greif, Otto Skorzeny's commando operation using captured American equipment. German soldiers had been equipped with captured jeeps, American uniforms, and fake identification, tasked with infiltrating Allied lines to cause confusion and capture bridges. If even Skorzeny, Hitler's favourite commando, was reduced to depending on captured American vehicles because German vehicles were insufficient, that revealed everything about the Wehrmacht's material situation. The operation failed. American military police quickly identified the German infiltrators through careful questioning about American culture and procedures. The Ardennes offensive itself ground to a halt, not primarily from American resistance, though that was fierce, but because German forces ran out of fuel. Panzer divisions abandoned their tanks when fuel trucks failed to arrive. Infantry divisions resorted to horse-drawn transport because motorized logistics had collapsed. By January 1945, the German attack had been contained and reversed. Spring of 1945 brought news of Germany's collapse. The Red Army closed on Berlin from the east. American and British forces crossed the Rhine and drove deep into Germany from the west. In the camp motor pool, German mechanics continued their work, maintaining vehicles for an army that had defeated their homeland. They felt no satisfaction in their work, but no shame either. Germany had lost not because its soldiers lacked courage or skill, but because it had challenged powers whose production capacity it could never match. One afternoon in April, an American soldier approached with news. Germany surrendered. War's over in Europe. The mechanics nodded. They had expected this for months. What happens to us now? You'll go home eventually. Probably not immediately. Lots of logistics to work out, but you'll go home. One mechanic considered this. Home to a Germany that had been bombed into rubble, occupied by foreign armies, its cities destroyed by the same manufacturing might that had produced the Jeep he had examined years ago. The American asked, "You're a smart guy. Did you really think Germany could win?" The mechanic thought carefully about his answer. Before the war, yes, we believed German quality would overcome American quantity. We had seen American products before the war, and many were inferior to German equivalents. We assumed American military equipment would be the same. But it wasn't. When we examined that first Jeep in '42, we realized we had made a fundamental error. We had confused peacetime quality with wartime effectiveness. Your Jeep wasn't better engineered than our Kübelwagen in absolute terms. It was better designed for mass production and field conditions. In total war, that proved decisive. The American nodded. Yeah, we build adequate products quickly and in huge quantities. Exactly. They stood in silence for a moment. Two mechanics from opposing sides, united by shared understanding of what had actually determined the war's outcome. The repatriation process began in late 1945. German prisoners boarded ships for the journey home. One mechanic arrived in Bremen in January 1946, processing through Allied control stations before being released. The city was ruins. Rubble stretched in every direction. But amid the destruction, he noticed something. American vehicles everywhere. Jeeps carrying Allied officers through the shattered streets, trucks delivering relief supplies, motor pools, where German civilians worked alongside Allied soldiers. He approached one motor pool, introducing himself to the American captain in command. His English, learned during years of captivity, was serviceable. "Sir, I am a former Oberfeldwebel of the Afrika Korps, recently repatriated from Camp Hearn, Texas. I am a trained vehicle mechanic with experience maintaining American equipment. Are you hiring civilian workers?" The captain examined his identification papers. "Says here you worked in our motor pool in Texas. That right?" "Yes, sir. 2 years." The captain made a note. "We need mechanics desperately." Most German mechanics either died in the war or are still in POW camps. "You can start tomorrow. Pay is in occupation script, redeemable for rations and necessities." And so the former Afrika Korps mechanic found himself employed by the army he had fought against, maintaining the same vehicles he had once examined as enemy equipment. The Allies needed mechanics. He needed work. The war was over. Life continued. Over the following months, he witnessed the beginning of Germany's reconstruction. American aid poured in, distributed with the same efficiency that had won the war. Food, medicine, construction materials, all arrived in American trucks coordinated by American planners who approached Germany's rebuilding systematically. He worked in the motor pool training young Germans in American maintenance techniques. Many of his students were former Wehrmacht soldiers like himself, men who needed civilian skills in a Germany that would no longer have a military. He taught them what he had observed: simplicity over sophistication, functionality over perfection, results over theory. These were lessons learned from American vehicles, applicable to rebuilding German manufacturing. By 1947, he had been promoted to supervisor of the motor pool's German civilian staff. The American captain who commanded the facility treated him with respect, valuing his experience and organizational skills. One evening, the captain invited him to share a drink in his office. "I've been thinking about something. You've worked with both German and American vehicles extensively. If you were designing a vehicle for the new Germany, what would it look like?" He considered carefully. "I would adapt the American approach for European conditions. Smaller than a Jeep, more fuel efficient, but maintaining the same philosophy. Common parts, simple maintenance, designed for manufacturing rather than engineering awards. Europe has narrow roads and limited fuel, but we need the reliability of American design thinking." The captain nodded. "That's smart. Marshall Plan money will rebuild German manufacturing, and German engineers are already studying American methods. The future is American-style mass production adapted for local conditions. This proved prophetic. In the decades that followed, West German manufacturing adopted American production philosophy while maintaining German attention to quality. The result was an economic renaissance that transformed Germany from a devastated nation into a powerhouse. Companies like Volkswagen, which had produced the Kübelwagen during the war, evolved into global automotive giants by combining German engineering precision with American mass production techniques. The Volkswagen Beetle, which became one of history's best-selling automobiles, embodied this synthesis. It was simple, reliable, manufacturable in huge quantities, and affordable for average families. Former Wehrmacht mechanics who had worked in American prison camp motor pools returned to Germany with knowledge that proved invaluable. They understood component standardization. They had witnessed efficient parts distribution systems. They had seen how simplified maintenance procedures increased vehicle availability. They had observed how designing for manufacturability rather than perfection enabled mass production. These insights, gained through years of maintaining American equipment, influenced German automotive design for decades. The German manufacturers that emerged from the ruins didn't try to recreate pre-war approaches. Instead, they synthesized German precision with American production efficiency. By the early 1950s, this hybrid approach was producing results. Volkswagen production ramped up from thousands of vehicles annually to hundreds of thousands. Mercedes-Benz adapted assembly line techniques while maintaining quality standards. BMW restructured its manufacturing to emphasize component commonality across model lines. The economic miracle of the 1950s and 60s owed much to these changes. West Germany became an export powerhouse, selling vehicles globally that combined reliability with affordability. The synthesis of German and American approaches created products that neither nation's pre-war philosophy could have produced alone. U.S. Army historian Hugh M. Cole, who interviewed Wehrmacht generals after their surrender, documented their perspective. Cole reported that German military leaders admired the Jeep more than anything else in the formidable American arsenal, not the B-17 bombers, not the Sherman tanks, not the artillery. The simple Jeep, because it represented the manufacturing philosophy that had actually won the war. General George C. Marshall himself called the Jeep America's greatest contribution to modern warfare. This wasn't hyperbole. The Jeep embodied principles that transformed not just military logistics, but post-war global manufacturing. Standardization, simplification, design for production, and emphasis on reliability over sophistication. By November 1943, the U.S. Army had enough data on captured Kübelwagens to publish Technical Manual TME 9803, a complete guide to operating and maintaining German vehicles. The manual was published on June 6, 1944, D-Day, enabling American forces landing in France to utilize any Kübelwagen they captured. The Wehrmacht never published an equivalent manual for the Jeep, despite capturing thousands. They didn't need to. The Jeep was intuitive enough that any mechanic could figure it out. This contrast illustrated the fundamental difference in design philosophy. The Kübelwagen required a detailed manual translated into English for American mechanics to understand its sophisticated systems. The Jeep required no manual at all for German mechanics to operate and maintain it effectively. The reunions began in the 1960s. Former members of the Afrika Korps, who had been captured in Tunisia, gathered to remember fallen comrades. At one such gathering in 1967, an impromptu discussion arose about the vehicles of the war. One former mechanic offered his perspective. The Kübelwagen was better engineered in many respects. Lighter, more fuel-efficient, excellent for desert conditions. But the Jeep was better designed for modern war. Four-wheel drive, simpler maintenance, common parts, and most importantly, producible in quantities we could never match. An old officer who had commanded a reconnaissance unit nodded. I remember capturing my first Jeep in '42. We thought it was crude compared to our vehicles. took us months to realize that simplicity was actually elegant efficiency. By 43, every unit wanted captured jeeps because they worked better under combat conditions. Another veteran added, "The worst moment for me was realizing that America was producing more jeeps in a week than Germany produced Kübelwagens in a year. That's when I knew we would lose, not from any particular battle, but from simple mathematics. They could replace losses faster than we could inflict them." This was the consensus that emerged from such discussions. German soldiers had tremendous respect for the Kübelwagen as a vehicle, but they recognized that the Jeep and what it represented about American production capacity had been decisive. The Wehrmacht's logistical situation had been dire throughout the war. By 1943, approximately 80% of German divisions relied on horse-drawn transport. The German army entered World War II with 514,000 horses and would eventually employ 2.7 to 5 million horses and mules during the war. Over 2 million of these animals died during the conflict. In contrast, American divisions were completely motorized. Every American unit relied on trucks, not horses, for logistics. This created operational advantages that Wehrmacht commanders envied. American supply columns could move hundreds of kilometers in a day. German supply columns, limited by the walking speed of horses, averaged perhaps 30 kilometers daily in good conditions. When Wehrmacht generals examined the reasons for their defeat, they consistently pointed to material disparity rather than tactical or strategic failures. German soldiers fought with skill and courage. German officers made reasonable tactical decisions. But German industry couldn't produce enough equipment to sustain operations against enemies with overwhelming material superiority. The Jeep became the symbol of this disparity because every German soldier who encountered one understood what it represented. Here was a vehicle so abundant that Americans treated it as disposable, so reliable that it required minimal maintenance, so simple that any soldier could operate and repair it, so effective that German units preferentially used captured jeeps over their own vehicles whenever possible. In 1976, the United States Army began replacing the Jeep with the HMMWV. The Jeep had served for 35 years, an extraordinary lifespan for any military vehicle. Many remained in service with reserve units and Allied militaries for decades more. The final Africa Corps reunion took place in 1998. Fewer than 24 veterans attended, all in their 70s or 80s, survivors of a conflict that had ended more than half a century earlier. During the reunion, someone mentioned that a local museum had acquired a restored Willys MB Jeep most wanted to visit. They stood around the vehicle, these elderly men who had once been young soldiers in Africa, examining it with the eyes of mechanics and warriors who had come to respect it. One veteran reached out to touch the hood, his arthritic fingers tracing the familiar lines. "I captured one of these in 42, used it for 3 months before I got wounded at El Alamein. Best vehicle I ever drove, better than anything we had." Another nodded. "I examined one in Tunisia just before we surrendered. Couldn't believe how simple the design was. Realized then that we'd been approaching vehicle design all wrong. Too complicated, too difficult to produce and maintain. They made over 600,000 of them." A third veteran added, "We made 50,000 Kübelwagens. That ratio told you everything." They stood in silence for a moment. The Jeep sat before them, a museum piece now, its war long over. But for these veterans, it represented something more than a historical artifact. It was a symbol of the production capacity that had defeated them, the functional engineering that had proven effective, the abundance that had overwhelmed scarcity. "We never had vehicles like this," one finally said. "Not in the numbers, not with the reliability, not designed with the same philosophy. We built for perfection. They built for production." Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.